Successful software starts at Raygun.com. Raygun APM provides .NET application performance monitoring unlike anything you've experienced before, offering greater clarity around how your software is performing for your customers more than any other APM provider. Easily detect and diagnose issues impacting end users and monitor every part of your stack in one powerful solution. You can monitor unlimited hosts, enjoy richer trace data and call stack information, and unblock those hard-to-solve performance bottlenecks that affect your web and mobile apps. It's time to get back to building great software instead of fighting it. Start your journey to better software quality and try Raygun free at raygun.com. That's RAYGUN.com today. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Glenn Vanderburg. He's the VP of Engineering at First, and a pretty darn good public speaker. I really enjoyed your talk on real software engineering.
Thank you very much. I'm always glad when people encounter that and enjoy watching it.
What does it feel like when you've done a bunch of talks, you've been speaking and writing and talking about software for many, many years, but then you do a talk and somehow it resonates more than the others and it becomes your best talk?
It feels great and a little bit intimidating. I mean, this talk, I've been giving it off and on for about 8 years, but even 8 years ago, it was the product of about 10 years of thinking and reading. And So it kind of almost feels like that's the peak, and I'm not likely to ever hit that peak again. But that's okay. If people are still asking you to give one talk after 8 years and asking you to give it again and again, that's a good feeling.
That is a good feeling. It is good to hit a home run. It does make you wonder if you'll ever hit a home run again. It's like, no, you really want this talk. Well, no, we want you to talk about this one. We're good with that. So you've given this talk many, many times, probably a couple of dozen, and you'd think it would get stale, but people like the talk, and it says something. The talk is called Real Software Engineering. You've done it as keynotes. You've done it several times, and there's videos of them online, and I'll make sure to put them in the show notes. What is the essence of real software engineering?
The essence of it is, I studied software engineering in college in the 80s and started trying to apply it at work in the 90s, and there was a way it was all taught then and something we were all aspiring to do to figure out the right way to build software. And it never quite felt right to me, and something always seemed to be wrong with that idea. And it took me, like I said, a number of years to get to the bottom of it. But the essence is that software engineering, like any branch of engineering, really isn't that prescribed and regimented. There's not just one way to do it. There are the essence is finding the right balance of cost and time to market and safety and robustness for the problem at hand, and figuring out the responsible way to build it.
What about the analogies that have been used, the extended analogies for many, many years about being an engineer and building a house versus being an engineer and building software?
Mm-hmm. People have an idea about how building houses is going to go. And the fact of the matter is that we've been building houses for a long time, and across the realm of engineering, that's like one of the best understood problems that we have. Even then, though, there are cost overruns often, and things aren't as stable as you might wish. It's not quite as predictable and rote, I guess, as people seem to think engineering always is. And furthermore, when people think of engineering, they tend to think of physical structures and civil engineering and bridges and things like that, and that's where a lot of the analogies come from. But there are a lot of different kinds of engineering, and some of them are very, very different from civil and structural engineering, and a lot more experimental and ad hoc like software is.
Why is it that we continue to recreate the wheel in software engineering? And there's, whether it be extreme programming 20 years ago or pair programming or sprints or agile. Like, we're all trying to figure this out. I am not a structural engineer, but it doesn't feel from the outside as a layperson that they're coming up with really revolutionary new ways to put up walls and stuff. Maybe they are.
No, I think there are several reasons for that. One is physical structures have at most 3 dimensions. So you can depict that in drawings. You might need a whole bunch of drawings to describe different aspects of the thing, but you can depict it in drawings and get really concrete, no pun intended, about what you're building. Software is abstract, and any program of any complexity has multiple dimensions, and it's more than 3, and I'm pretty sure the number is not an integer. Software is kind of fractally complex, and it's hard to visualize, it's hard to describe precisely, and a lot of what we're doing comes from experimenting with ways of communicating clearly, both to other engineers, but also to the machine, what it is we're building exactly.
That is really thoughtful, and that is a way of thinking about it that I had not done before. We say, and I have said, that it's really about communication. Like the slapping the keyboard part and the for loop is really secondary. It's, are you an effective communicator? That's kind of what separates the mediocre developers from the good ones. But what you're describing is that at least I can draw a picture and say, make it look like that.
Mm-hmm.
But we're still trying to figure out the right boxes and lines to describe the software, even today.
And because, and you know, we spent a lot of time, I talked about learning software engineering in the 80s and 90s, and we spent a lot of time investigating ways of depicting software in pictures. And none of that has been very successful. And part of it is the multidimensionality problem. And it turns out that the best way we know to really precisely describe software is in programming languages. And I think a lot of, you know, it's funny that this many years on, we're still inventing new programming languages almost as fast or faster than people can reasonably learn them. And you would think we would have figured out something, you know, and settled on it by then. But I think a lot of that is seeking ways to describe not only the precise idea, but the intent behind it of what software is and how it works.
Mm-hmm. Yeah, all of this is an expression of one's intent. And whether it be a picture is worth 1,000 words, and we draw the user interface and say this should look like this, there's never been a great way to express that. 1,000 words is a lot of words.
Yeah,
it is funny though that the language du jour or du the year, you know, is still happening. Like, and right. Now we ended up with the language that none of us really deserved, but it's the language we have, which is JavaScript. Like the least qualified language has become the one that everything's expressed in.
Mm-hmm. I was bemoaning that just earlier today. You know, you mentioned the picture is worth 1,000 words thing. I remember one conversation I had that really crystallized some of the thoughts in real software engineering for me was probably 13 or 14 years ago. I was having lunch with Dave Thomas of the Pragmatic Programmers, and I was wrestling with, you know, why UML sucked so bad. And I said, you know, the idea seems to make perfect sense. If a picture is worth 1,000 words, you know, why does it turn out to not be too helpful to draw pictures of our software? I mean, arguably it might help you communicate some things about it, but it doesn't seem to help us think about it very well. And he, in his wonderful way of piercing through, you know, misconceptions, he immediately turned around and said, animals can see pictures. Humans are creatures of language. And it just sort of totally turned that picture is worth 1,000 words thing on its head to, well, you know, maybe in some circumstances, but when you want to be precise about complicated things, language is a lot more powerful.
That's a tough one. I spent much of the 90s doing UML diagrams as well. And whether you were switching, and of course, for people who are maybe younger who are listening to the show, UML is the Unified Modeling Language. It was basically the boxes and the lines that they told us would solve all our problems. And a lot of time I just thought that, well, an activity diagram or a use case diagram or a state machine were just different lenses to look at the same problem. But then once there became 7 or 8 different diagrams, I felt like I kept repeating myself.
Yes.
And none of them said what I needed to say.
Yeah. And really, in order to get a full view of the system and talk about it with any degree of ease, you needed to be able to kind of rapidly move between those different views of the system.
Mm-hmm.
And the tools all made that kind of complicated and clumsy.
There was an article that was written in the Atlantic, an opinion piece a number of years ago that I thought was a little bit provocative. And it said, programmers, stop calling yourself engineers because
I've used a screenshot of that article in one of my talks. Yeah.
I felt that was a little bit aggressive. And it said, engineer is an aspirational title in software development. It basically belittled the entire engineer. And by us using it, it cheapened technology.
Yeah, I found that article really. I wish I had reread it recently and had it more on the top of my mind. But I found that article frustrating because in some ways it got so close to the truth, and in some ways it was so far. Engineering is an aspirational title, even for the traditional engineering field. It's it's one of the reasons I'm really passionate about using the word engineer and kind of reclaiming that for software developers. Mm-hmm. I've had people kind of ask me, why does it matter? Or are you just, trying to gain more respect or something like that? And mm-hmm. No, it's that using that name for yourself carries with it some expectations about the seriousness with which you take your field and the job you're doing, and trying to have some rigor around it and not be careless with people's money or lives or data or whatever. So sure, aspirational, that's fine. But then, in that article, when he talked about, he spent a lot of that article talking about and comparing software development to other engineering disciplines. And it was kind of funny because he made the same mistakes that people always seem to do of only focusing on civil and structural engineering, large-scale physical objects, which is the most unlike, it's the opposite end of the spectrum of engineering from software development. And also, he made it seem a lot more predictable and defined and prescribed than it actually is in the real world.
Mm-hmm.
One of the wonderful things about giving this real software engineering talk a couple of dozen times in different places around the world is that every time I do it, somebody comes up to me who is now a software developer but has a formal education in some branch of engineering or another. And sometimes they have some challenges for me and are able to correct me and help me refine the message of the talk. But most often, what I hear is, yes, you've got it exactly right. Engineering isn't what non-engineers think it is. It's always more creative and full of dead ends and blind alleys and iterating through mistakes and trying to get better.
Mm-hmm. Yeah, that's true. It really is a way of thinking. I always tease my parents when they call for tech support and they say, my mom literally emailed me about the router earlier. She's like, what should I do? And I don't want to be flippant, but I'm like, I don't know, man. I mean, unplug it. Like, I'm just going to poke at the thing, and the idea that we somehow have the answers and it is as structured. Sometimes stuff happens and you got to unplug it and plug it back in again.
That's right.
I don't know why that concrete mix is bad. Let's mix it again.
For years, I had this kind of bit of tension in my relationship with my wife where she would ask me how to solve some problem on the computer with a program she was using or something she was trying to do. And she has a programming background as well. Mm-hmm. So she's not the stereotypical tech support case, but she would say, how do I do this? And I would say, well, scoot over and let me sit down. and well, no, don't do it for me. Show me how to, or tell me how to do it. And then I'll learn. And for years, we were frustrated with each other about this until I finally understood myself well enough to explain to her, I don't know how to do anything on computers. I know how to figure out how to do stuff on computers. And that's about it. I generally don't know the answer to the question you're asking me, but I have enough, background knowledge and good problem-solving strategies to be able to sit down and poke around in the menus and figure it out. Mm-hmm. So, that was kind of a real turning point for us. And now she scoots over and lets me sit down and figure it out. And then I undo everything and have her sit down and tell her, explain to her what I did and how to do it. And it works out.
Well, it's kind of like, what's your password? I don't know. Let me touch the keyboard. My fingers
That's right.
know.
Yes, exactly.
This episode is sponsored by Datadog, a cloud monitoring platform built by engineers for engineers. Datadog enables full-stack observability for cloud infrastructure, applications, and logs in one tightly integrated platform. You can see across all your servers, containers, apps, and services in one place to monitor performance and make data-driven decisions. With rich dashboards and algorithmic alerts, collaboration tools, Datadog provides your team with the tools that they need to quickly troubleshoot and optimize modern applications. See for yourself with a free 14-day trial and receive a free Datadog t-shirt. Just go to bit.ly.com/DatadogShirt to get started. That's bit.ly, bit.ly.com/DatadogShirt. There was something that you mentioned before we started recording I wanted to talk about, which maybe apply to that as you move towards you improve your competence in something. It's the Dreyfus model of skill acquisition, which when looked at, it's 4 qualities: recollection, recognition, decision awareness, and then each of those qualities is binary. It smells like the engineer's equivalent of the Myers-Briggs personal strengths.
Yeah. Do you mean in the sense of not really actually being based on science and having any reality behind it, or
it appears to be like, let's put together a table and describe how one, how a way to think about things, whether it be Myers-Briggs or the Dreyfus model or, frankly, astronomy,
right?
Or astrology, rather. Pardon me.
The Dreyfus model is something. Another thing I learned about from the pragmatic programmers, and I may be completely butchering this in my memory, but my recollection is that Andy Hunt's wife is a nurse or is in the healthcare field, and so this came to his attention, and it's part of how the nursing field trains new nurses. And initially, your sole job is to learn to follow the rules. Yes, the rules are contextual and they're complicated and there's all kinds of situations. But as a beginning nurse, you don't think about that. These are the rules. You do it this way. You do it this way all the time. And as you grow in competence and gain more experience, you reach a point where you start to learn the reasons for the rules and the rationale behind them, and can start seeing some of the context that applies in those reasons. And then the third stage is you have enough understanding of the rationale and the context, and you learn when it's okay to break the rules and go off script a little bit because the situation calls for it and the rules don't apply here. And then for the fourth stage of really expert, experienced nurses, you've internalized those things enough that you don't think about the rules anymore. You act in the context that a patient is and deal with their problems and choose the right thing to do based on your experience. Brian Merrick has written about these things a lot from a similar perspective. His wife is a veterinarian and a professor of veterinary medicine, and she talks about teaching students to diagnose, cows. And it's not something so simple you can put into a nice, neat decision tree. Just takes a long period of apprenticeship where you walk through and, this one looks great to me. Well, no, you can tell it's sick because X, Y, and Z. And then they come to the next one and, it's sick. No, it's not. Well, you said it was sick if it was doing X, Y, and Z. Well, yes, but this one's also doing A, B, and C, and that means it's perfectly fine. And the complexities of a complex field with a lot of different things to think about.
I saw a wonderful viral tweet that was talking about the TV show House, when the doctor always seems to know, what the problem is. Like he's the Sherlock Holmes of medicine, right? So someone comes in with a rash and a fever and they're about to die and they're going tachycardic. And then the House is like, did you check his nose for raisins? And then, of course, at the end, everyone's like, "Of course! Oh God, the raisins! Yeah, raisins have that's exactly what." There's no flow chart would ever have sent you to raisins in his nose, but that was it, and that was the problem. And if you look at the Dreyfus model, when it talks about decisions, as you move from novice through competent to kind of proficient, your decision making process, as you point out, goes from analytical to intuitive, which, as I am becoming a senior programmer, and I say senior in the elder programmer way of the term, I recently solved a problem at work, and someone asked me, "How could you have known that?" And the only answer I had was, "Well, I'm old."
Yes.
I mean, I don't know how you teach a 22-year-old about, Unicode and bitness and Little Endian and, other than having been there.
Right, exactly. I pretty early in my career, 10 years in, I guess. So there's the old thing again. 10 years seems early in my career to me. I started noticing myself making decisions based on intuition and hunches. That felt really cool, but as a member of a team, I didn't think I could just get away with that all the time, right? You have to have some rationale, and whether you're justifying it to peers or explaining it to more junior developers that you're trying to help them grow and learn the things you know. So I didn't always do this, but I would kind of challenge myself to, okay, you made this decision based on a hunch, but that hunch had to come from somewhere.
Mm-hmm.
Your mind is distilling your experiences in this subcognitive way, but it's still a product of your experience. And so I sort of made this rough rule of thumb for myself that I didn't get to go and advocate for one of those hunch-based decisions until I'd kind of delved in and traced it and found a way to explain it rationally. Mm-hmm. Mm-hmm. And that was a tremendously useful exercise for me. And it helped the people around me too, but it also helped me to kind of resurface some of those older experiences and consciously think about how they'd shaped my thinking.
I have found that having a blog for 15, 20 years has been super useful, because when something happens, I think to myself, wow, okay, now I know that that's a thing.
Right.
I should probably write that down so someone else will know that that's a thing. And I recently spent about 16 hours debugging a segmentation fault on a Raspberry Pi. Yeah, exactly.
That sounds like a blast.
It was lovely. Best 16 hours of my life. And it turned out that I had been FTPing binaries in ASCII mode, and it was swapping out character return line. Yeah, exactly. So you laugh, right? You get the two old people laughing at each other. And the thing that was so ridiculous about that is when I started writing it up, I was like, oh, I should have seen that 20 minutes in. Like, what was I doing? And then when I wrote it up, as with all good blogs, the real quality is in the content of the comments. The commenters was like, oh, I knew it was that within 4 sentences.
Oh, of course, yeah.
I could see you crashing into the wall, and I couldn't yell to stop you, but it was fun to watch.
Mm-hmm.
But writing that up and understanding that, and then sharing it and making sure that people understand that failure and failing as fast as you can, as often as you can,
That's
is
right.
really how you become a good programmer.
Mm-hmm. And it's a big part of the essence of engineering as well. It
is, isn't it? But can it be? Like, how do we not knock buildings down accidentally, but we do allow software programs to fail?
If you're interested in what real engineering is like and the role of failure, the book to start with is by Henry Petrosky, professor of engineering at Duke University, I believe. Mm-hmm. He wrote a book many years ago called To Engineer is Human. And it's a book of essays about the role of failure in engineering and design. And in debates about this kind of thing over the years, I've heard many people say things like, yeah, real engineers have math so they can prove that their design won't fail. And yet, civil engineering designs fail every year to a greater or lesser degree. And fortunately for everyone, most of the failures are rather small scale, and or they happen before the structure is open or anything like that. But The bridge that collapsed in Italy earlier this year, tremendous tragedy. The ultimate, and the full reports haven't come out yet and everything, so I'm speculating based on what I read of other engineers speculating about it. But the fundamental structural flaw in that bridge was kind of around from the beginning. It was a cable-stayed bridge that used just one stay on each side of the tower. So it was a single point of failure, and it wasn't very resilient in the face of any of the kinds of stresses that would be applied to a bridge. And engineers in all fields are constantly trying to balance robustness and safety against cost, and trying to get their projects built and trying to meet their customers' budgets and things like that. And there are failures all the time.
That bridge, the Morandi Bridge, was being made in 1967, which you would think it wouldn't. Why would it? It should have broken in the last 50, 60 years. But then we have things like SSL or that are being broken, where it's like, wow, I wrote that code in the late 70s, and now that broke.
Right.
These things do happen. It could run. It can be robust and still break.
Mm-hmm. And robust in again, here's the context thing. Robust for most of the circumstances for which it was designed, but then you take it outside of the initial or original design center of that project and apply different kinds of stresses to it, and all of a sudden it's in a failure mode.
That kind of pops us all the way off pops off the stack all the way back to the beginning where you talked about context. My family asked me why they couldn't run Windows 7 anymore, and I said the internet is a different internet. Like if you want to run it unplugged, air gapped, please feel free. But if you want to put it on the actual internet, I would encourage you not to, because the context of the entire planet and everything has changed: hardware, software, connectivity. It was hard to explain that things are different now.
Yeah, security engineering is a particularly troublesome thing because it's always based on what you think is hard. And people are always finding ways to make things that used to be hard easy. And, even something as simple as the scripts that script kiddies run, right? You and I are old enough to remember when, you think about some of those crazy buffer overrun attacks and having to concoct just the right series of instructions to land at just the right memory address. And you think of how many times you'd have to do that before you found a computer where memory was laid out just so. And it's just, nobody would bother to do that. But then you wrap a script around it and automate it and figure out a way to test to see if it worked right. And you can do it hundreds of thousands of times. And all of a sudden it becomes easy.
I recently saw something really interesting where someone was doing fuzz testing on a FaceTime call, and they took over and crashed an iPhone simply by sending different pixels down the wire, and it upset the FaceTime codec and went all the way down to the beast, the bowels of the beast itself.
Wow.
Like, who would even think about that? If that's not real software engineering, I don't know what is.
Yeah, that's a particularly fiendish kind, but yeah.
Well, people can check out your talk, Real Software Engineering. You point out on your website at vanderburg.org that there's a number of different versions, and nicely enough, you've listed them in order of your preference, with the version from a conference called Software Art Thou as being your favorite version of that talk.
Yeah, that's a great little lecture series put on by Zendesk in Melbourne, Australia. They, periodically have a speaker in to do a talk there in downtown Melbourne, and they were kind enough to invite me, and they had a good audio video setup, and it's by far the best version of the talk.
That's fantastic. It's so nice when you do go to a conference and they've set it up such that they'll make the definitive version of that. It's almost like a stand-up comic getting the studio album done just so now we can put it on Netflix.
That's exactly it.
Fantastic. Well, thank you so much for chatting with me, Glenn Vanderburg.
Thanks for having me on.
This has been another episode of Hansel Minutes, and we'll see you again next week.